Okay, so we have a bunch of empty slides. I can continue on this theme of what we did yesterday, going through what is a approach in a power conversion on power electronics for invention versus what is not the good approach. And I emphasize that the power electronics is all about power conversion and minimizing number of components, devices, capacitors, switches, etc., and maximizing performance. Opposite what's integrated circuits, which you're putting as many transistors you want, it switches as many, and then adding capacitor, like capacitive switching is popular, and adding inductors. And I showed you that one inductor is useless because it carries DC power and it is a DC current, and therefore it is, as we'll get later, it is really useless as a component because it is extremely limiting in current and limiting in power and limiting in the size, Okay, so what I showed you yesterday is we used the original Ćuk converter that I showed demonstration before how I came up to it, and then a process in which decided, okay, you complained, and I think I'm glad some of these attendees to this course brought the case against the Ćuk converter, which has two inductances versus the buck boost and the flyback, which have a single inductor. So I hope yesterday I made a key point that we can eliminate this one inductor, and they said, hey, inductor is big and huge and stores energy, and switch doesn't store energy. The whole point about switches doesn't store energy, and especially with this DC switch, then we eliminated output inductor. Remember that yesterday? We eliminated input inductor and kept output inductor and get two converters. Both of them have isolation transformer, right? All right, so what would you do here? I replace output inductor with the diode. And that's one version, which is ended up step up with the isolation transformer, power factor correction, everything in one circuit. Then we have replaced the input with the inductor with the switch and kept the output inductor. So far, so good. We still kept just one inductor. Now I'm going to do one thing for you, and that is voila. Now I have a converter which has no inductances, no energy storage, capacitor charging, capacitor discharging. Well, is this going to be okay? Why not? What problem do you have that I showed you before that you should have a problem with this?
The cap gets shorted.
Because you have, remember someone yesterday said this is capacitive when I have inductor left in input or inductor left on the output, that is capacitive switching converter. It was not. There was still PWM inductor in it. Now we don't have PWM inductor, so what happened? Remember I told you capacitive switching only, or what is called the capacitive switching, what was introduced, it is inefficient because when you turn on a switch, this switch on, and this will force to diode, you will charge his. But you will charge this and then you will discharge in this way, but this will be like capacitive. This will be what the people did with the many switches and capacitors. I'm doing here with a single capacitor. You see, switch capacitor converters had 6 or 8 switches and 6 or 8 capacitors, right? I have only one capacitor, but that is a switch capacitor converter, isn't it? And what's bad with it, because this capacitor goes against DC voltage, which is fixed, and this has a ripple. And because you are trying to force this capacitor to eventually have a input voltage, the DC on it, and this capacitor here on the output will have will be connected to the output capacitor, and there are different ripples, so you'll get losses with this. So therefore it's a lossy. What is going to fix it? Wow, what is this now? This is your storageless converter, because during on time, I have one resonance with this CR and LR here. And then, because this resonant inductor, remember, just like showed in the hybrid switching, this resonant inductor says, I will get volt-second balance during on time only. And then, when this switch is turned on for 1 minus D, there is a resonance here. The same inductor, the same capacitor create different resonance. I mean, the same resonance, but what I'm saying in different part of interval. And then I'll have this this other resonance. So now you see that what I'm trying to point out. Remember, I showed you this presentation of Google when they had the switch 10 capacitors and then 12 capacitors, 5, 6 inductors, and a bunch of the switches. Here we have just 4 switches, and they are in a synchronism. These 2 switches operate together like voltage bidirectional switch, and this switch is like a split voltage bidirectional switching, because you have a transistor and diode, which is really voltage bidirectional switch, which maintains resonance only in on time or off time. And then looks like you're stuck. There is no way to regulate with the pulse-width modulated I showed that it's not true. You can actually, and we'll go through this remaining 3.5 weeks, we'll go through converter, which I call a storageless converter, which has resonance in one part of interval, the resonance limited to the other part of interval, but it can be still controlled with duty ratio, pulse-width modulation. Magic, right? So that is and what is this? What is this still not finished here? What is still possible? I need volunteers. Okay, so we go here. No, we go here. This one duplicate slide. What we didn't do yet on this one. I think we still have a red. Isolation transformer comes for free. I didn't do anything. Split the capacitance into 2 and then put inductors in between, and this is voila. This is automatic volt-second balance. There is no, and charge balance.